All right, welcome back for this last video, number 13. Take a look, 1 second. Had to close the door there. Okay, so we're looking at domain and range based off of a function. This one's a continuous function, which is the nice case. Right, so domain means our x values, right? So let's look at our leftmost x value. This is our x numbered line. Our leftmost x value is -2, and notice that it is a closed dot. So with a closed dot, we get a bracket. We move all the way until we get over to +2, in which it is an open dot, means it gets a parenthesis. So those are our x values. Now we're going to do the same thing with our y values. Right, our range is our y values. Let's look at our bottom y value, which is -5. Again, it is a closed dot, so it gets a bracket. And our greatest y value is a +2, which again, open dot, so it is a parenthesis. So that is the first case, the continuous versions. Continuous meaning you don't have to pick up your pencil or pen right here as you draw this. Those are the nice cases. Let's look at a not nice case. Right, so in this case, our domain, let's start with that. Notice there's a gap here in our x values. We're still going to go about the same format. So let's start from the left-hand side. Again, x value here is -2. It is a closed dot, so it gets a bracket. And we're going to keep traveling until we end up with an issue here. We end up with an issue at x equals 1, right? We come to a stopping point. It is an open dot, so it gets a parenthesis. Now, but there's nothing here between 1 and 2, so I have to skip over that area using a union. And now once I've skipped over that area, my next x value is this +2. Again, it's an open dot. It gets a parenthesis. And I'm going to keep going until I stop at 4, which is also an open dot. So it also gets a parenthesis, right? So open dots, parentheses, closed dots, brackets, domain, we're looking at the x values, range, we're looking at the y values. So for our y values, we look at our bottom value, right? It's a -5. Again, closed dot, we get a bracket. Now I understand that there's two graphs here, right? Or there's two parts, this piecewise function, but notice that as I travel, all my y values are covered. Right, I know there's a gap here, but it does not matter. We're looking just strictly at our y values. Do I have a y value at -5, -4, -3, -2, -1, +1, +2, all the way up to 3 is our greatest y value. And it has an open dot, so we are back to a parenthesis. Right, so domain x values, the range is the y values. And again, I know I'm going through these quickly, but feel free to pause at any point. Ooh, did I skip over? I skipped over 13. That was 14. So let's go back to 13. Sorry about that. Might need to use our whiteboard here. So it says the domain of f and the domain of g. Okay, good. These are good. So let's go ahead. These are both what we would call rational functions, meaning it's a function divided by another function, right? X divided by x squared plus 25. X minus 4 divided by x squared minus 16. A function divided by a function. So let's do f first. Now, the issue that you would normally see here, let's scroll down. The issue you would normally see with a rational function is, well, we know we can't divide by 0, right? So let's write down this first one. This is f is equal to x over x squared plus 25. And so we know normally when we're dealing with rational functions, we run into an issue, we can't divide by 0, meaning our denominator cannot be equal to 0. So in order to avoid this problem, I want to figure out where everything's going to go wrong. Or in other words, I want to find out when this is equal to 0. And so I take my denominator, x squared plus 25, I set it equal to 0, and I begin to solve. Now what you'll notice here, this is kind of a special case, right, if I take the square root of both sides, right? I also know that I can't take the square root of negative numbers. So in other words, this is never going to happen, right? There's never going to be an x value that I can plug in square it, and get a negative 25. Right, so in this case, you'll actually never be equal to 0 in your denominator, and so you get all of your x values, right? There's no x values that you have a problem with, right? Another way of saying no problem with any x values is I get all the x values from negative infinity all the way to positive infinity. And remember, infinities always get parentheses. Right, so again, the step that we're going to do in the next one is going to be the same, but you'll see how it's different. Right, you take your denominator, you set it equal to 0, and you're trying to figure out the x values where this would be true, right? When does it equal 0? If it equals 0, that's going to be a problem with my domain. In this case, no problems, right? X squared equals negative 25, that's never going to happen. Now the other one, and I'll write that in a second, is, I believe it's this, x minus 4 over x squared minus 16. Now there's there's something to mention about this. We're not going to talk about it quite yet, what's known as a hole in a graph, but we will just keep on with the following of what we did before, right? We want to figure out where are the domain issues, right? It's still going to be the same process. I take my denominator, I'm going to set it equal to 0, and I'm going to solve, right? If I move the 16 to the other side, I have x squared is equal to 16. And if I take the square root, I can take the square root of positive numbers. So I get plus or minus the square root of 16, which gives me plus or minus 4, right? So I have two answers here, negative 4 and a positive 4, right? So notice here, in our previous problem, x squared can never be a negative value. That's why there was no issue here. Down here, x squared can be equal to 16. That's not an issue, right? Or I mean, that is an issue, right? It can be equal to 16. And so if you take negative 4, right, and you square it, you'll get a positive 16. If you take a positive 4 and you square it, you'll get a positive 16. Right, so both of these answers, right, both x equals negative 4 and positive 4 cause an issue here. Right, so because they cause an issue, I don't want them to be in my domain. Well, how do I make sure they're not in my domain? Well, we start off on the left-hand side. Negative infinity. I'm going to keep running until I run into an issue. My first issue here is at negative 4. I'm going to jump over this issue to the other side of it. I'm going to keep running again until I run into another issue. And I'm going to jump over that one as well. Right, so that negative 4 and positive 4, right, they cause an issue because that would force us to divide by 0. And we do not want to deal with that. So we need to skip over negative 4 and positive 4, right? Those are the issues in our domain. So this is our solution. I'm going to go type these in, though, so you can see what they look like typed into Alex. All right, so the domain of f, parenthesis, negative infinity, positive infinity, parenthesis, and the domain of g, parenthesis, negative infinity, we run into an issue at positive, or negative 4, sorry. We jump to the other side of negative 4. We keep going to a positive 4. We run into another issue. We jump over positive 4. We go to infinity. So all those are also parentheses because, again, we can't divide by 0. And if we plugged in negative 4, positive 4, that would be equal to 0, so I can't include those, right? So that's why those are getting a parenthesis. Okay, so that's the two main things we saw. That's a rational function. Let's look at the square root, right? So as we've mentioned before in class, the issue with the square root is I cannot take the square root of a negative number, right? Cannot take the square root of a negative number. And so we can take the square root of 0, right? Square root of 0 is 0. That's a common, easy mistake to make. And so right now I have h of x is equal to square root of x minus 1. And again, I can't take the square root of negative numbers. And so what I'd like to do is, well, let's find that boundary point of 0, right? I can take the square root of 0. And so I take this, and I set the square root of x minus 1 equal to 0. And if I do this, right, I square both sides, I get x minus 1 is equal to 0 squared, still 0. So that's the good news. And we end up with x equals 1. right? So you can think of this as one of our boundary points. Now, some of us may be wondering, we have two options right now. Is it our lower boundary or is it our upper boundary? Right? If you immediately know upon looking at this which way you're supposed to go, that's fine, right? But I just sometimes, it's not as easy maybe when the signs are switched or anything like that. So I list out both values and you can always test it, right? Meaning, if I look at my option 1 here, and let's plug in another value other than 1. Let's say 2, right? Does this work? Well, square root of 2 minus 1, square root of 1, this is totally fine, right? I get 1, check mark. However, let's say for instance I plug in 0, right, which would be over here. If I do 0, I end up with square root of 0 minus 1, or in other words, square root of negative 1. And again, I can't take the square root of negative numbers. So I know that this one is out of there. This is gone. And so I'm only left with this, right? Again, if you immediately know once you find that one value on the rest of the interval, that's fine. And again, the difference here is 1 is included, right? Because I can take the square root of 0. So 1 here is included. 1 minus 1 is equal to 0, square root of 0, that's okay. So I have bracket 1, say bracket 1 comma infinity, and infinities always get parentheses. Again, I'm going to keep moving. Still a few problems, right? That's 13, 14. We still got 3 more, but you can see these all have multiple options, so I at least want to get one of each. Okay, kind of hard for me to do without having this here, right? If I want to, it says finding the slope given the graph on a grid. Remember, if I get 2 points here, they've given me 2 points. I'm going to just list these out, right? What are my 2 points? 0, negative 2, and positive 2, 4. 0, negative 2, positive 2, 4. And I really just say it twice so I remember it. So we have 0, negative 2, positive 2, 4. And we just need to know the slope of this, right? So we know slope, which is abbreviated normally as m, is equal to rise over run, or in other words, y2 minus y1, all over x2 minus x1. And so in our case, it does not matter which one you decide to be x1, y1, x2, y2. Just make sure you keep them in the same order, meaning I'm going to go ahead and say this is my y2 over here, which is 4, so minus my y1, negative 2. And the reason what I mean when I say keep this in order, I called this one y2, so this one has to be x2. So then I do 2 minus 0. Or in other words, 4 minus a negative 2, 2 minus 0. My slope I get is a positive 3. And so maybe a good idea might be when you first get these points, label them, right? I'll call this one x1, y1. So you just so you don't lose track, and I'll call this one x2, y2. It's not a bad idea. We get a positive 3. That is all it wants. Let's go ahead and we'll keep moving. That was finding the slope. Okay. If it gives you the 2 points, this is the same thing, right? I'm going to assume this is okay. I mean, I'll do it again. Negative 5, 1, negative 7, 6. Negative 5, 1, negative 5, 1, negative 7, 6. Same thing, same idea. And so we're right back to the previous problem, right? The first one's a little bit more because you just have to go grab the information from the graph. And again, let's practice what I just said. Let's say x1, y1, x2, y2. It doesn't matter, but just so we don't lose track of it. And so I have y2, which is 6, minus y1, all over x2, minus x1. And so I have the ugly negative 5 over 2. Perfect. All right, let's keep moving forward. That takes care of 15, so we get 2 more. I'm going to do this one first. I might leave one of these as kind of a... Yeah, these ones are nice, right? So the slope of a parallel line, right, if you're considering this line, it has the same slope. The slope of a perpendicular line has the negative reciprocal, right? Flip the fraction, turn it to a negative. Let's see if there's any other, there's one more, right? So this one, don't be thrown off because you're like, well, what is this? Well, the slope here is just 1. And if you flip it, it would still be a 1, but it'd be a negative 1, right? Yeah, I might have to leave 16. So there's one question you have to do on your own. It says find the slope of a perpendicular line and the slope of a parallel line. And so I'm going to write this down and I'm going to switch the format so it's a little bit more familiar. I have 5x plus 2y is equal to 3. And there's just an extra step here, right? 5x plus 2y is equal to 3. And let's get it into y equals mx plus b format. So I'm going to move over the 5x. If I subtract 5x on both sides, right, I get 2y is equal to negative 5x plus 3. If I divide both sides by 2, I get y is equal to, this 2, this is an easy thing to forget. This 2 goes with each piece. Right, the 2 gets distributed to the negative 5 and the positive 3. And so now once we have this, we're back to our previous problem, right? The slope of our parallel line, normally denoted like this, is negative 5 over 2. However, the slope of our perpendicular line, normally denoted with this little symbol, right? We flip the fraction, so now we're at negative 2/5, and we change the sign. So just an extra algebra step there. Double check to make sure this was done right. Ooh, so I am going too quick. Let's see. Negative 5 says, oh, because I didn't read. That's okay. Right, look what I did. Be careful, it tricked me. It says perpendicular line first. I was like, wait a minute. Try it again. There we go. Okay, let's do this last option here. Identifying parallel and perpendicular lines from equations. And so it's really just, right, in this case, right, all we're going to be doing is simplifying. Right, simplifying and moving things over. And we haven't done one of these, so let's do it. I'm going to 6x minus 4y is equal to 4. 6x minus 4y is equal to 4. And I'm just going to, again, I like y equals mx plus b format. So if I start solving for y, I just care about the slope here, right? So I get y is going to be equal to, well, I'm distributing that negative 4 to each piece. So I have positive 6 over 4 x plus 4 divided by negative 4, so minus 1. And if I simplify this, right, 6 over 4 is 3 over 2x. And so again, I care about this right now. This is line 1. Now I'm going to go repeat this for line 2 because I don't think it's in a good format either. So let's go check. So just so we can see, we just did line 1 here and the slope was 3 over 2. And if you look at line 3, the slope is also 3 over 2. So we know that line 1 and line 3 are parallel. So let's go ahead, we can get rid of that one. Let's go ahead and look at line 2. Now you can kind of already see it there, right? 2y is equal to 3x plus 5. Right, line 2. 2y is equal to 3x plus 5. And if I divide both sides by 2, what also happens? I get the same slope again, right? Y is equal to 3 over 2x plus 5 over 2. So again, all these lines have the same slope. So if all the lines have the same slope, guess what? They're all parallel. So I know, again, I did that quickly for this. Put everything into y equals mx plus b format, or in other words, the same format as line number 3 here. And it's going to make it a lot easier to see whether lines are parallel or perpendicular. So that takes us to the end. I did leave 16 as a mystery. I'll let you take a glimpse at the name of it if you would like. It's just on writing the equation of a line. All right, so 16, finding the slope and y-intercept of a given line, and writing the equation of the line through 2 given points, right? So that's 16 for you. I'll post, I shouldn't say, as soon as you're watching these, you'll know they're posted. But other than that, I'll check my messages tonight to see if there's any questions, and I will see you tomorrow.